Alright, today we'll be working out the surface area of a sphere. And how we're going to do this is a little bit strange, but I hope it's interesting. We're going to blow the sphere up into a whole bunch of tiny little bits. And we're going to show that these tiny little bits actually form the same area as a cylinder that just surrounds the sphere. So the radius of the cylinder would be the same as the radius of the sphere, and the height of the cylinder is the same as the height of the sphere. All right. And the way we're going to do this is we're going to blow the cylinder up into all these tiny little bits as well, and we're going to show some equivalence between the bits. Now, it won't be very formal. I won't get into the full details of it, but it will just be fun to see, I hope. So how we're going to do this is we're going to see that if I just take one little ring of these little bits around the sphere, then the really interesting thing is that this ring has the same area as the ring with the same sort of height on the cylinder. Now, I know it doesn't look the same, but it actually is, right? And again, I won't get into the full details about why, but if we take this ring back to the sphere and we look at it from the side, then what we can see is that this ring actually is a little bit diagonal. Right. So the cylinder's ring would be completely vertical, but this one has a bit of a diagonal slant to it. Right. And if you know a bit of trigonometry, you can actually show that this diagonal slant makes the sphere's ring a little bit fatter, and the amount by which it makes it fatter actually perfectly cancels out the fact that the cylinder's ring has a larger radius. So these two rings actually have the same area. Right? The sphere's ring being thicker cancels out the fact that the cylinder's ring has a larger radius. Okay. But what this means then is that rather than think about the surface area of the sphere, we are free to just turn the sphere into the cylinder and use what we did last time to just think about the surface area of the cylinder. Or more precisely, just the cylinder's roll part, right? So the cylinder has a radius of, well, the same radius as the sphere would, while the height of the cylinder is actually the length from the north pole of the sphere to the south pole, which is made up of two radius lengths, because it's like you've got to go to the center, then go to the south pole. And so the height of the cylinder is actually 2r. And so what's the area of just this roll part? Well, from last time, we saw that that would be the circumference multiplied by the height, which is 2 pi r multiplied by 2r. And when we've got that, well, 2 times 2 gives you 4. Then you've got the pi. And then finally, r times r gives you r squared. So let's see an example of an object that combines what we did last time with the cylinders with this new sphere stuff. So here's an object that is a cylinder with a hemisphere, half a sphere, stacked on top of it. We'll say the diameter is 48 meters and the height of just the cylinder part is 30 meters, and we are looking for the surface area. We've probably picked up by now the important measurement isn't diameter, it's actually the radius. So we'll first note that the radius is half of the 48, which is 24 meters. And then we're going to color in each face as we go to make sure we've added them all up. So let's start with the bottom. That's just going to be pi r square. Now, normally for a cylinder, there's 2 circles that we need to account for, but because the top of this cylinder actually isn't part of the outside of the shape, we need to throw it away, right? Because it's not actually on the outside, so we don't need to count it for the surface area of the shape. So that means we only have the 1 pi r square that we need to account for. Then we have the roll. That's going to still be 2 pi r multiplied by h, the circumference multiplied by the height. We need to count all of that. Okay, so let's do that bit first. We can put in the values for r and for h. That's 24 for r and 30 for h. And we might hold that for now, okay, because we're not finished yet, so no calculator yet. Now we look at the dome. That is the surface area of an entire sphere, but then divided by 2 because we only have half of the sphere. And so again, we can just plug in our value for r, it's 24, and now we can just add up those two values for our total surface area. Okay, and so that's a surface area of a sphere. Thanks for watching. I'll see you later.